In this video tutorial, we shall see the simulation of the program to find out the sum of even and odd numbers. First, we have to create a folder on the desktop by your ESN name. For example, 4VV19AC, your ESN, right? After this, you have to copy the necessary files. So 4 files will be pasted on the desktop. 2 of them are the startup files which are required for all the programs. lcd.c and lcd.h will be required only for the keypad program. So I will copy these files inside this folder. Fine. Then I have to create a project. So click on Kyle Micro version 4. If any project is open, you can go to project and close project. Then click on project, new microvision, browse to the desktop where you have created your ESN.
So this is my ESN. So you can give the same ESN name for your project 4VV19EC00. Click on save. Here search for LPC1768. Select this and click on OK. It will ask whether you want to add the startup file. Say no. Then you have to come to the options for target. Click here. Click on output and enable create X file and click on OK. Now I need a main file and a .s file. So before that you can add both the startup files. Okay. So because I have selected the file type as C, only C is available. Select this and just click once. Next select ASM. So your assembly files will be visible. Select this and click on add. So both the files are added to the project. Okay. Then select source group 1, right click and select add new item. Now I want to have a main.c, so I will select the file type as .c and I will give the name as main. No need to give the extension in this option, it will automatically take. Fine. So my main.c is ready. Next I want an assembly file. Right click, add new item, select ASM and give the file as odd even sum and click on add. Fine. Now I will start coding. So in the main you can include first the header file hash include lpc17xx.h, then int main void. Now see here, please follow this for all the programs. The moment you open the brace, please close the brace. Right, then you can start writing. Give a tab, okay, at least 4. Now here the first is initialization of the system. So for that the function is system init. Right, and this is case sensitive. For example, if you write this s in small, it will be an error, or if you write this I small, then also it will be an error. So in system init function, s as well as I are uppercase. Then I have to call my assembly function. So for that I will give the name odd even sum, open the brace and close. The same name I will be using in odd even sum.
In case if you have used uppercase and all, make sure that you have written the same. Then while. That's it. Okay. Now starts my assembly program. In the assembly program, first I need to define the area. So give a space in capital, write area. Then my data, comma, data, and because this is both read and write, I will write read and write. Fine. Then I will define the odd and even numbers without giving space. So num, I will define all as 32-bit words. Define double word and give some data 1, 2, 3, 5, 7, something. Then to store the even sum, so even sum you can initialize with 0 or you can put a question mark, anything is fine. Then odd sum, right? So this is the memory being allocated. Okay, remember here there is no space when you start them, whereas when you write area there is a space. If you don't provide space, it will give an error. So this is the data space. Now similarly you have to write the code now. Again give space, area, my code, and this is read only. Okay, then export, give the same name which you had given in main. So this is the name I had given, so I will give the same name, right? Then again without giving any space, start from the first position, entry, then the same name, that is odd even sum. So these things are very important. We have noticed that students have done mistake here. Where to give space, where not to give, many or not aware. Okay, wherever you start with the mnemonic, please give the space. Okay, now you can start typing the program. The first thing is to initialize a pointer to the memory. So you have to give a space. Okay, at least one. Okay, I will give a tab. So LDR, I will use R6 as a pointer, which is pointing the memory location now. So this is pointer to memory. After this, I will initialize a counter for odd sum, move R2 comma hash 0 and move R3 comma hash 0. So this is for odd sum and this is for even sum. Then how many numbers I have taken? I have taken 7 numbers, right? So initialize the count accordingly. Many people have done mistake in IA. For all they have taken 5 itself. Okay, so as many as the data has been given, the same count should be reflected. Okay, so I have taken the count now. Now I have to check what is the logic. Read the LSB. So first I will read the first number. For that the instruction is LDR. I will read in R0 register, R0 comma R6 is a pointer, and because I am reading a 32-bit word, so every time the pointer will be incremented by 4 bytes. Okay, so the data will come in R0. Now I will check out whether the LSB is 1 or not. See, when you write and is, it will not show in blue color, but still it's a keyword. Okay, so and R0 with hash, this is very important, 0 0 0 4 zeros 5 6 7 1. Okay, so this will tell you whether the number is even or odd. For even number, the LSB is 0, whereas for the odd number, the LSB is 1. So if the number which we have read in R0 is odd, then we will get a non-zero value in R1 and the zero flag will not be set. In case if the number is even, fine. In that case, we will get a 0 in R1 because for even the LSB is 0. So that's the logic. Okay. So after this, zero flag will be affected. So we need to check the zero flag. For that, the instruction is branch on equal to even. It means what? If you have got a zero flag, that is if the zero flag is set, then it is even. If not, what should you do? You should increment your odd counter. So my odd counter is in R2. So add R2 comma R2 comma R0. So I'm adding the odd numbers. Add odd numbers. Okay. Then I don't want the other instructions to be executed. So I will branch on next. What if it is even? See, all the labels should start from the first. This is even. Okay. If it is even, add R3 comma R3 comma R0. What will this instruction do? It will add the contents of R0 with R3 and store the result in R3. So this is for add even numbers. So this we will repeat for all the numbers. Okay. So after this, I have to go to the next number. So I will have the label called next. I have to update the pointer, right? So subtract. So I have to update the count. My count is in R4. Subtract R4 comma R4 comma hash 1. If this count is not equal to 0, then to repeat this process. So branch on not equal to back or any label which you have given, and back will be here. Okay. If it is equal, what? You can terminate and you can store the result wherever you want. So I have planned to store the result in even sum. So initialize a pointer LDR R6 equal to, what is the name I have given? Even sum. Fine. And my result is in of even is in R3. So str R3 comma store in the memory. So this is my even sum. Similarly, we can store the odd sum. So this is for odd sum. So the name I have given is odd sum, and I have to store the odd number. So my odd sum is in R2, right? That's it. So then again branch to the main program using the link register, and end marks the end of the assembly. Okay, I will just repeat few things which are very important. First is, wherever the keyword starts, you have to leave a space. Okay, so here area is a keyword, export is a keyword, all these are keywords. Labels to start from the first. And please see this syntax of all the instructions carefully. Then you can compile.
So you can see there are two warnings here. One is you can just put a new line. The other is function odd even sum declared implicitly. The reason is I have the definition of odd even sum is here. So I have, if I want to use it in main, I have to make this as extern. So here you can write extern the same name odd even sum, and no returns, extern void odd even sum. Okay, let us compile again. Now we can go to debug. Okay, you can close the disassembly window, no need. You can close the command window, you can close the all the windows. What I need is the memory windows. Okay, so go to view, click on memory window and click on memory 1. Okay, now how to execute? For these two you have to step over. I don't want instructions in system init to be executed one by one. So here is what is step over. So once you click on this, the entire function will be executed, right? But this I want to execute one by one. So for this, either you can press F11 or you can click on step. Fine. Now, once you execute this instruction, you will come to know what is the address taken by the num. Okay, and that will be available in R6 register. Okay, so now I will execute this. So you can see the address it has taken is 10000004. So double click here, copy this by pressing Ctrl C, come to the address bar and paste it here by you pressing Ctrl V and then press enter. Now you can see whatever the data you had initialized is visible here. Okay, the first one was 01, so the lower byte has come, the others is 00. So because it's a 32-bit data, 4 bytes have been occupied. Next it is 2, 3, 4, 5, 6, 7. Okay, now you can start executing. So what should be my result? So odd numbers are 1, so 1 plus 3 is 4, 4 plus 5 is 9, and 9 plus 7 is 16. 16 in decimal means 10 in hexadecimal. So odd sum will be 10. What will be even? 2 plus 4 8, 8 plus 6 14. So E will be the even sum. Okay, so execute step by step. So the first number is an odd number. So I will read the first data. So you should see 1 in or not now. So you can see 1 has come, and you can also observe the 0 flag. Now it is 1. Let us see after this execution what will happen. Now if you see, the 0 flag has become 0. Okay, because the result is not 0. So branch on equal to will not be true. So that will come to the next instruction. Okay, so the first number is 1. The same thing will be added and it will be stored in R2. And I don't want this instruction to be executed, so it will branch to next. So now the counter was 7, it will become 6, and these things will be repeated. The next is 2. Now if you AND, you can see the 0 flag is set now, so this condition will be true, and now it will branch to even. Okay, and it has added the even numbers. So this result is repeated for all the numbers until your counter becomes 0. So you can see R4 is 1 now. Now R4 has become 0, so it will come out of the loop. Okay, and it will store after this number 7. So my 7 is here, so my result will be stored somewhere from here. Right, so you can see the result has been stored. So that is even sum, and this is odd sum. So we got 1 0 and 0C. 0C is your even. How is that? Yeah, 6 plus 4 is 10. 10 plus 2 is 12. Right? So this is how you write the program, simulation program, and execute.